So if you're not aware of the existence of project production systems, then what you're going to be hearing today is going to be pretty much Greek or a waste of your time. It's not going to make much sense. Trust me, been there, done that. So to help create that foundational understanding that really everything you're going to hear about today is built on, let's get started with our first speakers. They're Todd Zabel and Roberto Arbelo, who neither one need much of an introduction. Todd is the founder of Project Production Institute now 10 years ago. It's our 10th year anniversary. Woohoo! And he's president of Strategic Project Solutions. Todd is really a leading edge thinker in the application of operations science into capital projects, as well as Roberto. Roberto is a senior vice president at Strategic Project Solutions and an instructor at PPI. He has over 20 years of experience in helping project teams use this stuff to drive project performance and optimize their projects. So with that, I'm going to turn it over to the two of them, and they've got a really good foundational, set the foundation for us on what project production systems are all about, how they differ from schedules.
Well, thank you very much, Gary. I'm excited to go through this presentation with Roberto. Really the objective here, and it's a fairly simple presentation to get across the idea of the paper that we've put together to decipher between what is a schedule and what is a production system. And we see some confusion out in the market, for lack of a better word, primarily due to the fact that the people that are involved in construction, and Roberto's a civil engineer, my background as a contractor, we see the world through a lens of schedules. And even when we begin to talk about new conceptual frameworks, such as the project production system, which began in the mid-90s with the Lean Construction Institute, we can't get our head around that for some reason, right? The thinking is deep into schedule. This is very problematic. Why is it problematic? Because as we're going to see, the production system actually dictates what happens on a project. And not only does it dictate by not engaging and understanding that there is a production system, how to manage it rather, there is significant amount of value leakage that occurs. If you truly want a predictable project outcome, I'm not saying that you want to accelerate, reduce costs, conserve cash for everyone. If you truly want to predict project outcomes, you'll see that it's less about studying the schedule and more about studying and understanding the production system, how it's going to behave. All right. Roberto will come at the end and give some examples. This is not what I would call a very technical paper, but it is a mind shift, and we have to cross the river to understand the difference between the two. Okay, so I think we're all pretty clear on what a schedule is. And really the purpose of a schedule, when you think about it, is to determine what needs to be done when and who will do that at that particular time. Schedules are very commonplace in our industry. They're the basis of many things. They allow us to forecast, again, when we might need things, when we might need entities to come and do work, contractors, suppliers, so on and so forth, design firms. They allow us to base things on procurement. For procurement purposes, we can do reporting and forecasting of progress. We could do financial reporting. We could understand cash flows. They have many things that they're used for today as part of the project process. They are as fundamental in the world of construction as pretty much anything. But they're only half the story. The other half of the story is what we call the production system. And the production system, simply put, is all the processes, entities that are required and that actually do the work. Now, you could see here that this diagram is different than the diagrammatic element on the previous slide that's showing a bar chart, perhaps created using the critical path method scheduling approach. All right. These are two separate entities. One is the plan on what we want to have happen, what we think might happen. And this is actually a representation again, of the processes and entities that'll do the work that actually tell us what will happen. Okay, we're going to delve into that a little more. The graphical mapping language, if you will, is very different. In production system thinking, you'll see that on this particular diagram, there are green rectangles and blue barrels and triangles and arrows in between. The arrows tell us what the flow of the work is, right? Or I shouldn't say, excuse me, not the flow of the work, the flow of the items through the production system, okay, the routing. The rectangles tell us where the operations are or process centers. The triangles denote a queue. That means every time work's done and it's handed off, it's either going to queue or it's going to be in a stock, which we would see as a barrel. It's pretty hard to have an operation, which is denoted by the green rectangles, and not have a queue or a stock afterwards. Even extremely high volume manufacturing still has that situation occur. In the world of production, and Gary alluded to operation science, when we look at these types of flows, we're interested not only in how long does a particular operation take, the green, we're equally or even more interested in how long things are waiting in the blue. And so if we truly want to measure time, we cannot only measure the green, we must take in consideration the blue. All right, we're going to talk about this a little bit more, and Roberto is going to show you some real world stuff in just a moment. All right, so we alluded to this somewhat about the relationship between schedules and production systems. And so I'm going to go slow here, and I really, really want to punch this up, and hopefully this you're able to take this in. All right, it's really critical to all that we're doing here at the Project Production Institute. In our mind, the way to see this is that the schedule sets the demand, what we should or want to have happen. Okay, and it is done through the means of dates. Right, so we take something has to start at a particular date and end at a particular date, and that will release another activity, if you will, to occur. Again, that's the demand side. That's what should or what we want to have happen. On the other side is what we call the supply side, the production system. The production system's job is to respond to the demand. It is essentially all of the entities that do the work. And so be thinking equipment, humans, and so on and so forth. All right. How you define a production system, whether you're saying, I only want to look in at the design portion, Roberto is going to show that later. I only want to look at a particular value stream, if you will, concrete from, let's say, batching through installation, or you want to look at the work as part of a specific system, it's up to you to define the production system. But the production system, and I really want to punch this up as much as I can, is not a schedule. It's not depicted by a schedule. And if you look at this through the lens of a schedule, you truly will struggle, as Gary's saying, to understand what's going on, all right, on the production system side. If you're able to cross the river and get to one side, I see back the schedule, and I'm standing on the side of the production system, what we're going to show you here will all make sense, all right? So the way we need to look at this is that the schedule and the production system work as two gears, right? Production system saying what needs to be done. The schedule saying what needs to be done. The production system's doing it or not doing it. Right now, production systems are a very interesting thing. If we go back a slide, for the most part, these entities already exist. There's engineering firms, there's architectural firms, concrete firms, steel erectors, steel fabricators. I think you get the idea. The list goes on and on. For the most part, for most projects, it is a matter of plugging and playing through the procurement process these entities together and their associated value streams to make production systems. All right. So we're not really designing new entities. right? Sometimes we put someone in business, but for the most part, we're taking existing entities and we're putting them together to create the production system. That alone is a very interesting concept, right? We're plugging and playing constantly. And what's interesting in construction is participants in the production system, or entities, if you will, are moving in and out of the overall production system. So it's a little more complex. We're not a fixed plant that's doing final assembly of automobiles or whatever the case may be. So we have a somewhat dynamic production system in the sense of how the entities are moving in and out. Okay. So again, and I'm not trying to beat a dead horse, but I really want to drive this point home. There is the demand side, the schedule, what should happen, what we want to have happen, and it's done through dates. All right. And then it's used to measure progress on how well are we achieving what we should or want to have happen. That is a completely separate thing from what we call the production system that will deliver to that. All right. So again, when we talk about a production system, another thing that we need to understand is the work flows through the production system. So let's take structural steel. If we have to fabricate the steel that we're going to cut, we're going to weld the connections, let's say in the shop, we're going to deliver it, and we're going to erect it. What we're looking at from the production system perspective is not when will that be done per a schedule. We're looking at the flow through the production system. So I'm not certain what it says here, but let's say on the far left, again, if this was structural steel, I'm not certain what this is, but there would be raw materials, and those things go from raw material or even engineering, and they flow through the system. The system doesn't move over time. To make it as simple as possible, if you print the production system map and you put it on the wall, it's only this big. On the left will be a bunch of inbound things, which could be for engineering or architecture requirements. On the right will be things such as steel erected, and in the middle will be all the work in process or work underway. Okay. This map doesn't change throughout the process. It may not change for many years within an entity, a company. As a matter of fact, once you create this map, and Roberto will show how these are changed into a model, it becomes the digital twin, the representation of a specific production system, and it only changes if you decide to change it. It doesn't change over time, right? It's not related to time. These aren't tasks on a schedule and time. These are operations, process centers, queues, and stocks that the work flows through. All right. And I think that you're going to hear this theme from the guys today working on the production system. Again, this is a big idea and unlocks significant value to get your head around this. This is not a schedule depicting what's going to happen in time. This is a process flow diagram depicting what the routing is of the items that flow through the production system, where they're being worked on, where they're waiting to be worked on. And from that, we can start to build out many things. Okay. Gary alluded to operation science. We're not going to get too deep in this, but there are underlying mathematical equations and relationships that govern how a production system is going to operate. Okay. Again, I'm not on the schedule side. We're not talking about project controls. We're talking about the network of entities that are going to deliver the project. And so from that perspective, we're talking about the relationship between how much utilization of the capacity you have, and the more the utilization of the capacity, the longer it's going to take. The cycle time will go out. The more cars you put on the highway, freeway, motorway, the more traffic, the more congestion, the longer it takes. A production system like the one we saw before in the map can only get so much throughput, amount of items through the process for a given time. It can only give so much until it maxes out. All right. And so no matter how much more you push in, and WIP is work in process, not progress, no additional work is going to come out. All right. And then finally, there's the relationship between WIP and cycle time. If you continue to push more into the system and the WIP continues to grow, the time's going to go out. Now, people are very interested in cycle time and throughput. It's very important to us. How long is it going to take and how much time do we have to get this stuff done? The schedule sends us over basically the tack time, which means we need to deliver every hour, day, week, month, this amount of stuff, right? And so what we want to do is determine, do we have the throughput and is our cycle time of our production system able to do that? This is not difficult for specialty contractors or fabricators to fully understand. Once they understand really what we're talking about is the schedule comes from the customer, the client, the CM, the owner. It tells them, here's what you need to produce. This is what we're looking for. This is what we want to have happen. And the first question is, do we have the throughput to do that? All right. Now you'll see some dotted lines here. And those are related to, on the two ends, utilization, WIP, variability. We don't necessarily need to get into that right now. That'll be for others. But an interesting thing in this is you cannot change the cycle time or the throughput. Those are measurements. Those are key performance indicators. What you can change is the utilization, right, of the capacity of the production system, and you can control the WIP, right? Those are two of the levers that you can play with if you want to change the cycle time and throughput. But in order to do that, if you go back a slide for a sec, Roberto, you need to understand what your routing is. You need to understand what your operations and process centers are, the blue. You need to understand where your stocks and queues are, the green, okay? And so the capacity is related to these things as well as the WIP, right? The WIP is the sum of anything with however you define it in the system. And let's say it's end to end, all the work going on. What's the work in process? Remember, the more the WIP, the longer it takes. Remember, the production system drives the schedule. The schedule suggests to the production system, here's what we like to have happen. Okay. Next one, please. Okay. I'm going to hand this over to Roberto to take you through what most of us in construction like, which is the real world examples of how you could go take the production thinking coupled with the operation science to do some highly predictive modeling. Okay. So I want to be as clear as I possibly can. And I'm going to start off with a question. Think about when you do an analysis on a schedule, a risk analysis. You're doing an analysis on how effective you are at planning, because a schedule, if you look in the dictionary, is merely a plan. And this to me is very profound. You are doing an analysis to see how robust you made your plan. Okay. And things end up in court and claims and the rest, and claims consultants and attorneys arguing about how robust was the plan. That is a different question than how robust is your production system, and can your production system deliver to the demand? All right. Now we've at SPS, speaking on that side, have stayed away from introducing the concept of production system analysis in the world of claims and that whole legal world. All right. But if you think about this, we are analyzing and arguing over the plan, when in reality, it's the production system and our decisions around the production system, including doing things like figuring out how to increase tool time and so on and so forth, which may be related to utilization, but the higher the utilization, longer it takes, right? Have implications for the project cost, duration, and use of cash, right? So just be thinking, what we're doing here is we're not analyzing the robustness of the schedule. We're analyzing the robustness of the production system. And any schedule, anytime, anywhere is only as robust as the production system that delivers it. So I would argue even analyzing the schedule is not very interesting. Analyzing the production system is what's critical. With that, Roberto, I'll hand it over to you to show some examples.
Thank you, Todd. Good morning, everyone. Let's dive directly on one example. I'm going to share a few things about this example, which is associated with the hookup and commissioning scope of an offshore platform. And hookup and commissioning basically happens offshore, right? And when you build an offshore platform, you go to a yard and you do the jacket, you do the topside. These are the components of a platform. But this particular scope happens 100% offshore in the middle of the ocean, actually on the platform. What you see here is the use of the master schedule that is predicting 139 days of duration for a particular scope, the hookup and commissioning. If you look at the orange, not the blue, the orange line, what this team did is look at the production system model, plug in the different contributors of capacity, and determine that the duration will be much longer, 213 additional days than the schedule, number one. And so one thing the team did is to check, right? Almost do like a pressure test of the production system and found this quite significant gap, as you can see, right? 230 days is, much more than the duration of the schedule, right? The blue line represents the same model, assuming that there's infinite capacity, which is not even true, right? And so what the production system model was actually telling the team that even if we max the capacity, or we basically put a lot of no limits on capacity, we are going to struggle to get closer to what the schedule was saying. Okay, so that was one of the first outputs of this initial effort. Then the question is, so now what we do, right? The team used the 5 levers of production system optimization to define different strategies on how to compress the time as much as possible. We couldn't, in this case, the team couldn't modify the design of the asset, right? It was too late for that. And therefore, the attention focused on the other 4 levers, right? The process design, right? How the work is actually batched, for instance, right? What are the issues with the current capacity contributors in the system, right? And remember, capacity and resources are not synonymous, by the way, right? We're talking about the capacity of the production system. Inventory, as in work in process, as Todd mentioned, and stocks and variability, right? And so playing with these 4 different levers, we started looking first at where the problems might be coming from. And as Todd introduced in one of the 3 curves, which is the one that talks about capacity utilization and the impact to the queue time and the cycle time, the team actually focused on analyzing specific resources that were basically stretched to the limit. And as you can see, this is just an example. We have scaffolders, riggers, and the people doing the painting and the blasting. And so what these charts show, these are outputs of the production system model the team created, is that at different points in time, these particular resources are, have capacity utilization that's beyond 100%. So it's not a single event or a one point in the whole spectrum when the production system is up and running and operational that this is happening, but it was a systemic problem with the scaffolders and the riggers and the painters, right? The chart below just focuses on the riggers. This is once again for illustration purposes. And it shows that the green, what was initially considered in the schedule, as it shows here as planned, and the blue, what the production system says is going to be required, and how these requirements change over time, right? And so identifying the bottlenecks in production terms, the bottleneck is an operation or several operations which will have more than one bottleneck at any given time, or actually even moving over time. What is the issue with those bottlenecks in the system? Okay, so that was one of the first steps. Then what the team did is use production system modeling and some leading edge technology to start analyzing very rapidly some alternative strategies on how to get to the original target, as much closer as possible to that target, right? Remember, in an offshore platform environment, in the oil and gas business, you need to have the asset built as fast as you can. Otherwise, getting access to the revenue, extracting the oil, extracting the gas, will be compromised. So speed becomes an important factor for the business. What this is showing is, and let's concentrate on this little box that says strategy, there are multiple strategies being analyzed in the production system model through multiple iterations. As a matter of fact, although this is not necessarily showing all of them, there were about 24 different delivery strategies and combinations of, let's modify a little bit of the batching of the work, let's play with some of the resources, let's also factor in variability and things as you saw in the levers before. But as you can graphically see, the current strategy, what the team was actually planning to do at that time, so I see my mouse here to highlight, all these dots are multiple iterations with the same strategy. It's like a cluster of options, right? Coming out of the production system model, right? What you see on the top is a statistical distribution of what happens with these different options, right? And as you can see here below, for duration, right? This curve on the top, it relates to the duration. It's about 325 days as an average, right? Which is what we were showing previously. Okay, but that is not going to help us, right? What we're seeing is that if we don't make any changes to the current strategy, or even if we start making simple changes like extending working hours, right? A simple one, 20% or even 40%, that is not going to help much. But as we start playing with the bottleneck resources, when you see here BN, mean bottleneck resources, the riggers, the scaffolders, and we try to increase their capacity or increase the resources in order to release the bottleneck, we can start having some significant impact, right? Similarly on the cost and what happens with the direct labor, particularly on this particular case, okay? And each of these alternatives has its own distribution on what is the likelihood that this is going to happen, okay? As Todd mentioned, this is not an analysis on the schedule, it's an analysis on the production system, right? This is not about doing a P50, P90 type Monte Carlo analysis on the schedules. This was actually conducted through a discrete event simulation analysis and modeling of the production system, okay? And why is this so important? Because the team, those especially in management positions, gain access, right, through this analysis and optimization to different options that they need to now make a decision about, right? Things that they could do. Not necessarily all these options are actually viable options. And we will explore that in a second. What do we mean by that? In an offshore platform type environment, as you can imagine, you're in the middle of the ocean, It's not that you can just add resources at will, right? You don't have a space where to put people unless you bring a flotel, sometimes it's called that way, right? Or unless you have existing beds capacity on the platform itself, right? And so the different alternatives need to be analyzed to see if the available capacity for the workers, the available bed capacity, excuse me, for the workers will or not be compromised, right? And so in the work vessels that could actually, these are vessels that are temporarily moved next to the platform for the workers to stay, we didn't have, the team did not see any problems with the capacity of these vessels in terms of the number of beds. But what was exposed is that if we start increasing these different options, 175 of the bottleneck or 2 times some of the bottlenecks, we start seeing issues with the amount or exceeding the amount of beds on the platform itself. POB means, for those of you who are not aware, mean people on board, persons on board, okay? And so there were some limitations, right? Not that you can just play with different options. And this is one way, this is just to illustrate. In other examples, if you work with, let's say, a downstream type facility, which is not offshore, but is onshore, similar limitations might actually be in place, right? You might have space limitations. You cannot put people in the same space or more people in the same physical space, or you might have restrictions about how many people can get into an existing refinery at any given time during the day, right? And so you need to check these real limitations as we go through. Now, a couple more things. This particular chart, and there are many things on it, so I need to be clear about what this is telling us. If you look at the green lines, they show the rate at which the team was opening and closing what they call job cards. Job cards are smaller chunks of work, right? It's a subset of the schedule, if you will, right? A smaller chunk of work. It could be work worth 1 day. It could be work worth, I don't know, 4 or 5 days, right? And the blue means what the model is actually predicting is going to happen, right? This project is actually being executed as we speak, right? And so we don't really have the end of the story, but what we have been able to do, the team has been able to do with the red lines, they're actually analyzing the speed at which they are able to open these job cards and closing them, right? And the closing is this line below, which is far from the actual even prediction of the model. So this is happening because there is a lot of work in process being created in the system, as well as the team is exposed to more variability levels than they originally thought, right? And the combination of the actual information with what initially was planned and also with the prediction of the model is what is currently being used to determine not only the speed, but also the working process. As you can see, the same colors relate to the schedule, the model, schedule, order plan, the model, and the actuals, right? And so the model requires that we have more working process.
Roberto, we've got some good questions and we've got 5 minutes left.
Yep. So I'll finish in 1 minute,
Okay.
hopefully less. For illustration purposes, this also shows, if you look at the red line here, the welders, this is another example of fabricating a jacket, where the schedule shows that this is going to be, over time, the profile for the use of welders, but the production system depicts a completely different picture of obviously less amount of resources, but a completely different profile. On this other side, it's a bit of a different picture because the production system model depicts that you will need more resources than the plan, and it's a completely different profile, right? This goes back to what Todd said of the production system is really what is going to dictate what happens, and these are just examples of what he meant by that. And to finish, a bit of the...
Can we just go back for 1 sec? part of the 1 minute. This is a great representation of the schedule versus the production system. The schedule is saying what is needed in the way of resources, welders, or riggers. The demand, the schedule says this is what we believe is needed. When you look at the production system, it's saying this is what will be provided. And it's the relationship between the two that we see in one situation. There's insufficient amount of capacity that'll be in the system due to the resources, and the other one, there's too much. And this is the matching problem that we're talking about. Okay. These are the two gears, and they're different views. I can assure you, and we live this every day, the production system will ultimately dictate what's going to happen, not the schedule. Okay, why don't we wrap up? There are some excellent questions.
Yeah. So we leave you with three ideas. Project production systems, the framework behind it is not really well understood. Scheduling is being used to map what is believed to be a production system, resulting in significant loss of value, a lot of surprises, right? And a lot of people want to be predictable, and the production system is the one that we should be looking at in order to look at predictability. Understanding and learning how to manage production systems will deliver those predictable outcomes, okay? So Gary, thanks for the time, and over to you for some Q&A.
Yeah, so let's looks like we have time for maybe one question here.
Let's sneak in two.
Okay,
we'll go fast.
All right. I think you almost just answered this for this question. I'm not grasping how this is different to how scheduling is fundamentally supposed to be done. Isn't the schedule typically supposed to mirror the production system in terms of linkages and duration is dependent on work versus resources? Or are we saying that planners don't understand the fundamentals?
Yeah, I don't think we're saying that at all. Planners, for the most part, focus on creating schedules. That's a good thing. What we're inviting planners and others to do is to actually look at the production system. To know if you're looking at a production system, you usually have to go visit facilities and build models that aren't used, that don't use bar charts. They use process flow diagrams. So if you're not working in process flow diagrams, if you're not doing time studies, if you're not at suppliers or visiting other sites to see what's going on, you're probably not looking at the work. You're probably not looking at a production system. Yeah. Let's go through a few more here. We can go fast now.
Okay, how does tacket planning figure into this? There would seem to be fewer barrels using tacket, referring to the flow diagram, and here in the production flow and where in the production flow is buffering?
Yeah, that's an excellent question. So TACT to us is a means of doing scheduling. So it's on the left side. There's many means: critical path, last responsible moment, so on and so forth. So it is on the left side, a means of doing scheduling. Go back one. Go back a little bit further, Roberto. All right, so it's the left side. TACT is a very interesting concept, and if you run a production system model, what you're going to see is a loss of capacity, because as you try to synchronize time, if you will, that is going to cause issues due to the variability or variation in the different players on the production side. I'm not saying it's a bad thing. I'm just saying that you need to understand from a production perspective, what does that mean? If I'm a subcontractor, I'm probably going to feel that TACT is a little antagonistic to me, because I might be going up and down with my resources. Okay.
Okay, one more quick one. So if it's a supply chain problem, what is best practice strategy in this case? Efficiency or responsiveness?
That is the question. That is an excellent question, and it depends on what it is that you're trying to accomplish. The good news is you can choose between efficiency and responsiveness. Ideally, what you want to do is get to the desired responsiveness, which in the world of operation science would be termed the service level, all right, as efficient as possible. Once you get that dialed in, then you're going to have to make a decision on that. If you go to a grocery store, they get responsiveness by having food in stock, right? So usually when you want to have responsiveness, you have some level of inventory, or you have a lot of available capacity, like the fire department. They sit around and wait for the call and can respond. So that is an excellent question that's asked every day because efficiency and responsiveness are directly related to cost and use of cash.
All right, excellent. Well, we're going to have to move on to our next topic. Thank you all. That was excellent foundation, excellent grounding, and I hope folks are connecting with it.